Okay, thank you very much. We'll move on to Sydney Veres, Capstone. She is supervised by John Caspersen. The external supervisor doesn't appear to be here. However, Sydney's family is here. So thanks for doing that. And over to you, Sydney.
Yeah. Hi, everyone. My name is Sydney, and my capstone is titled A Comparative Study of Post-Harvest Stream Condition in the Skeena and South Coast Natural Resource Regions in British Columbia. This past summer, during my internship, I largely assisted with block layout, and this included conducting a lot of stream surveys and helping to employ the proper protections. And so I was interested in investigating how effective current protections are in BC at conserving streams and their adjacent riparian areas during and after logging operations. My capstone examines post-harvest stream condition between the Skeena and South Coast natural resource regions. I chose these two regions because I thought it would be interesting to compare to different places in the province in terms of topography, natural and anthropogenic impacts, and historical logging. And I inferred that they would have a difference in their post-harvest stream condition. Streams in their adjacent riparian areas are important because they perform various essential ecosystem functions such as energy regulation and control, nutrient cycling, water sedimentation and transport, and habitat provision. Small streams support unique species that are not found in other areas of the watershed, such as amphibians, invertebrates, and aquatic insects, while larger streams provide fish habitat. Forestry operations impact streams and riparian areas in several ways. Notably, logging and post-harvest windthrow can negatively impact streams by decreasing canopy cover, which increases light and water temperature, and also modifies leaf litter and downwood debris, which is the base of the aquatic food web. It can destabilize the bank, leading to erosion and increased sedimentation, and can also lead to decreased water infiltration and storage, just to name a few. So how are streams currently protected during forestry operations in BC? Current legislation that governs riparian areas during logging is the Forest Range and Practices Act, or the FRPA. Along with it is the Riparian Management Area Guidebook, and this provides best management practices to comply with the FRPA. The guidebook introduced the concept of riparian management areas. This consists of a riparian management zone where constraints to harvesting exist, for example, retention, and where applicable, a riparian reserve zone, which is a fixed width buffer zone directly adjacent to the stream that prohibits harvesting. However, not all streams have this buffer zone. Management zones depends on riparian stream class. So in BC, streams are categorized from S1 to S6, with S1 being the largest fish-bearing streams. These streams have the largest management zone and reserve zone and the highest amount of recommended retention, while S6 streams are the smallest non-fish-bearing streams. They don't have a reserve zone, and they have the smallest management zone with the lowest recommended amount of retention. However, while S6 streams don't have these buffer zones, a 5-meter machine-free zone is often employed under best management practices. So while machines can't cross into this 5-meter area, harvesting can still occur. It's also important to note that different companies and licensees follow different best management practices and prescribe levels of retention on a site-specific basis. So my capstone focuses on 3 main objectives. 1, determine how post-harvest stream condition differs between the Skeena and South Coast natural resource regions. 2, identify the main drivers of impaired stream functioning in both regions. And 3, evaluate if current practices are sufficient to protect streams during and after harvesting operations in each region. The data used for my capstone is public data sourced from BC's Forest Range and Evaluation Program, or R.P.F for short. This is a government program that monitors resource values impacted by forestry operations. All sample sites are randomly selected from BC timber sales cut blocks that have been harvested in the last 1 to 3 years, and this is to reflect recent logging disturbances. R.P.F monitoring uses 15 questions to assess the post-harvest condition of a stream and the surrounding riparian habitat. Each of these indicator questions produces a yes or no answer. So yes being that the stream characteristic is healthy and functioning, or no meaning that it is not. The number of no answers for each sample are directly linked to different variables, the first being condition category, with more no answers signifying a worse condition. No answers are also linked to disturbances, where each no answer is assigned one or more of these disturbances to explain the impaired functioning. I conducted my statistical analysis in RStudio, and a 95 level of confidence was used to test statistical significance, and I use ArcGIS for mapping. Results of the chi-squared test showed that there are significant differences in the proportion of all streams across condition categories between the two regions. This was supported by a two-proportional z-test that showed that the Skeena region specifically had a larger proportion of streams in the top two condition categories and a significantly lower proportion of streams in the bottom two condition categories compared to the South Coast. And this suggests that the Skeena has better post-harvest stream condition overall. Results of the chi-square test also showed significantly different proportions across stream classes between the two regions. However, in both regions, S6 streams were sampled the most out of all regions, all classes. This doesn't necessarily mean that S6 streams are the most abundant throughout the entire region. Once again, sample locations are based on cut blocks. So this more likely reflects that S6 streams are more likely to be located in or adjacent to cut blocks, and therefore are disproportionately exposed to logging. But results of a z-test show that the South Coast does have significantly higher proportion of S6 streams compared to that of the Skeena. Putting these three variables together, I used a proportional odds regression. I did expect to see that S6 streams have significantly worse condition compared to all other stream classes because they do receive the least amount of protection. However, stream class, as well as the interaction of region and stream class, did not show significant associations with condition. This suggests that stream condition does not vary significantly across stream classes between the regions. While not significantly different, the stacked bar chart shows that S6 streams in both regions do have a slightly higher proportion of streams in these lower condition categories. Results from a Permanova indicated that logging explained a large proportion of multivariate disturbance variation. This suggests that logging is the dominant disturbance on streams in both regions. This makes sense because samples, once again, are taken from cut blocks that have been recently harvested. However, the proportion of logging as a disturbance is greater in the South Coast compared to the Skeena. So looking specifically at the impact of logging, results from an ordinal logistic regression show that the probability of logging as a disturbance increases with smaller stream classes. Notably, S6 streams were found to have the highest median of logging of around 2.5, where all other stream classes had a median of around 1 or 0. However, there are various outliers. This could just reflect the low sample size for all other stream classes other than S6 streams. But overall, this does suggest that logging impacts S6 streams more than all other stream classes. Average retention and condition for S6 streams specifically was found to have a significant relationship. Specifically, results from an ordinal regression show that in both regions, lower retention is associated with worse stream condition. However, this negative relationship was found to be significantly stronger in the South Coast, suggesting that lower retention levels results in even greater declines in stream condition in this particular region. And this suggests that S6 streams in the South Coast may require a bit more protection. What's also interesting is that S6 streams tended to be assessed as properly functioning when there was around 15% retention in the RMZ and the Skeena and around 18% in the South Coast. While S6 streams with 5% retention or below, which is the current recommended level of retention under best management practices, tended to show at least some form of impaired functioning. Finally, to understand specific effects of logging on the streams in each region, I identified which indicator question received the most no answers, indicating impaired functioning for a specific stream characteristic. In the Skeena, this was question 8, suggesting that S6 streams were most often impacted by too much inorganic sediment in the stream. Based on literature, it's likely due to logging too close to the stream, which exposes the subsoil and destabilizes the stream bank. And this is what leads to erosion and sedimentation. In the South Coast, this question was question 15, suggesting that S6 streams in this region are most often impacted by disturbance to the vegetation within the first 10 meters of the stream bank. Overall, results show that post-harvest stream condition in the South Coast is worse than that of the Skeena. However, in both regions, S6 streams were found to be disproportionately exposed and impacted to logging. In the South Coast, this pattern is greater, which may explain why the South Coast has worse overall post-harvest stream condition compared to the Skeena. And although logging impacts S6 streams differently in each region, the root issue seems to be the same, which is a lack of retention. Overall, this does suggest that current protections in BC are not effective at protecting S6 streams during and after logging operations. As S6 streams are often at the headwaters of a watershed, their condition can significantly impact larger downstream reaches. Literature suggests that insufficient retention on S6 streams not only negatively impacts those specific streams and the surrounding riparian habitat, resulting in declines to biodiversity, but also leads to the degradation of larger connected streams, impacting fish habitat and overall watershed condition. And so even if a larger downstream reach has sufficient protection, it can still be negatively impacted by the impaired functioning of a smaller upstream reach. Overall, this highlights the importance of proper protection of S6 streams for the broader ecosystem. So how can BC riparian management be improved in these regions to help protect these streams? My first recommendation is to increase levels of retention in the riparian management zone for S6 streams in both regions from 5% to 15%. My results suggest that retention plays an integral role in protecting S6 streams and their riparian areas, and therefore it's likely that increasing this retention will help to mitigate the negative impacts caused by logging. Moreover, as results suggest that S6 streams in the South Coast are even more exposed and impacted to logging than the Skeena, my second recommendation is, rather than having a 5-meter machine-free zone, implementing a 10-meter buffer zone for these S6 streams to provide that extra protection that streams in the South Coast may require. Overall, my project highlights, while regional differences do exist across BC, S6 streams may be undervalued across the entire province. This highlights the need for current forestry practices surrounding the protection of smaller streams to change. Because if we better protect our S6 streams, we will be able to better protect all of our streams. Those are the references. Thank you for listening. Thank you to John. Thank you, John, my internal supervisor, and Bernie, my external supervisor, who couldn't make it today, and the MFC 2024.
Well done, thank you very much. One of your conclusions was that the retention, or the lack of retention, seems to have a bigger effect on stream condition in the South Coast. Is that right?
Yes.
And based on our previous discussions, that I think you said it has to do with cumulative effects. They didn't elaborate as much on the box, so I was wondering if you could just discuss that a bit more. Yeah, and what exactly do you mean by cumulative effects? And maybe just restate the result here.
Yeah, so my results showed that in both regions, a higher level of retention was positively associated with better or proper functioning streams post-harvest. In the Skeena, a retention level of around 15% was needed to ensure proper functioning. And then kind of 5% and below, there was some sort of impairment to that stream. And then in the South Coast, it was higher, around 18%, and the pattern is a little bit clearer. In terms of cumulative impacts, as we had kind of talked about earlier, I wasn't able to find significant results from the data that I used. But literature suggests that logging has been kind of more continuous in the South Coast. Also looking at my maps, the South Coast, all the cut blocks are a lot closer together. So in terms of streams being, closer together and more connected, impacts to one stream might have a bigger chance of impacting an adjacent stream if the cut blocks are closer together. And streams might also just be experiencing like previous historical logging that occurred more frequently in the South Coast, whether compared to the North, logging kind of started relatively more recently.
So I can understand the cumulative impacts associated with historical effects. In other words, if there was some previous logging, but these are all previously unlogged, or
That actually wasn't part of my data, so I'm not sure.
you're not sure, okay. And then, but I mean, I'm just wondering, but these are this is across all, no, this is just for S6, right? So these are pretty small streams. I'm just wondering if there could be upstream, like if there's logging upstream or historically logging upstream. How far up, like, I guess my question, I'm trying to formulate my question here. If you have a small stream, where does that stream start? Like upstream, like is it like a kilometer, or how far away does that upstream effects go?
I mean, yeah, it's definitely, it depends on the specific stream, like stream.
Yes, I guess.
How far upstream? Sorry.
Yeah,
I
so
think
like,
you're going.
if you walked up, so you went out there, you were out there doing
Yeah.
4 days of your own. You, based on what you remember from the S6 street, if you walked to the end of it, how long would you have to walk?
So, I mean, typically it wasn't walking to the very end. It was just, we do the stream survey in the block and then kind of walk 100 meters outside of the block. Sometimes though, these streams were just coming straight out of the ground. So it's like, that's kind of what I mean by headwater streams. Sometimes like they are at the very top of a watershed, but also upstream factors could definitely be at play. For example, if there were roads above the cut block or even above the reach in the block, that could definitely have impacts on an S6 stream lower down through runoff and sedimentation in that way.
Well, you do have another question, right? I'll give it to Zeke and you can have another question.
Your job today, you did a fantastic job illustrating how important it is to protect smaller bodies of water, especially when they have their working place. I was curious to hear your thoughts on, obviously with the S6 streams, the buffer is so small originally. And I was kind of curious to hear your take from your experience in the field on whether you thought the buffer was not just ineffective, but also if it was actually being enforced, and if maybe there was operational error, and maybe how to mitigate those risks if you think that's an issue.
Yeah. So when I was working, I was mostly doing pre-logging operations, so I didn't actually get to see the condition of streams afterwards. As someone who kind of helped employ these protections, I know myself, I tried to, follow what was prescribed and to the best of my ability, like leave a little bit more of a buffer as well. But I also had experience firsthand where like that wasn't always the case and sometimes needs to be modified. And so in terms of ensuring that these protections are actually employed, I think it just needs to be kind of prioritized more in general. I think since the buffers don't exist and the retention is so small, then people are not taking the protection seriously, and maybe it's a little bit can be more wishy-washy than like a bigger fish bearing stream that it's really more prioritized.
Yeah, just to follow up on that, do you think that the prescription of a standard buffer, which is kind of a blanket prescription on any stream that meets the definition, do you think that is enough, or would you like to see a different kind of policy shift in terms of how we do protect our waterways?
I think in terms of the buffer zones, it's kind of hard to make site-specific prescriptions because I think that could be great in terms of maybe increasing the buffer zone, but it could also potentially go the other way, where people don't employ as much of a buffer zone if it's just kind of up to whoever is the one prescribing those. But I think in terms of retention specifically, best management practices, I think then yeah, like a more regional approach or more stream specific approach might be need to like be more focused on in that way.
Can we go to Richard and then John?
Your presentation said, I was kind of adding what you said. I was wondering if you had any thoughts on kind of expanding the stream classifications kind of beyond what is typically done, because an S6 can vary from one to another. Whether that be expanding it beyond the typical classification system of measuring and slow angle, or if you had any thoughts on that.
Right. I know from my research that often S6 streams particularly are sometimes classified as like important S6 streams and not important S6 streams, which I mean, on the one hand, could be good because, you know, if it's more important, then more protections could be prescribed, and maybe breaking up classifications into more specific kind of categories can better help people to understand like the different levels of protection needed. But I think that that kind of notion of important versus not important is just like inherently problematic in terms of S6 streams, but also the larger stream class in general. I think a big reason why these larger streams have a lot more protection is their presence of fish. And just because S6 streams don't have fish, they are automatically deemed as less important and receive less protection. I just don't think that's necessarily the case or should be the case. When I was out there doing stream surveys, like I, you know, look at a rock and see 5 different types of moss and see little frogs jumping around. And I just think that there should be more of a priority on these small streams.
We have quite a few questions still. Just get to John, then we will.
Oh, I might be a little bit boring, so go to the first floor.
Go ahead. I have an exciting question. John says, sorry, an exciting question here is, so Skeena area is, the geology is
Yes.
than the lower areas, so it's all sedimentary kinds of things, and I was wondering how that could impact weather, the concerns. It's much more prone to erosion and so forth. And then I also wonder how good are these data? This kind of, you know, people are asked to go, does the in-stream invertebrates look healthy? And they go, yes, no.
Yeah.
How good are you with that?
I mean, I can't speak to, I mean, how in-depth the actual monitoring was because I wasn't following this exact procedure and collecting the data. I will say for each indicator question, it's not as simple as, you know, yes or no for each question. Typically, there's at least 2 to 4 sub questions that are asked to answer the broader question. What kind of I think could be improved on is because all of this data is collected 1 to 3 years post harvest. I think that's great in terms of seeing the immediate impacts of logging. But I think that what would really be more beneficial is also going back to these sites again, maybe 5, 10 years down the line and seeing, are these streams actually able to bounce back or are they continuing to decline? And I think that that would make the data a lot more interesting and maybe more effective as well.
Go ahead.
Great presentation said. My question kind of piggybacks on what Cynthia and Richard were talking about. It was more so related to the best management practices themselves. This may be more like an ignorant question about everything. Are these best management practices, are they like enforced through policy where they have to follow them? Or are they more so just kind of left up to the discretion of the actual individual enforcers when they're kind of deciding that? And is there like a regulatory framework that if they don't follow it, they get punished or something along those lines, or?
I can't speak to the punishment. I will say, so, the widths of the riparian management area and then the management zone and reserve zone, these are like fixed width areas, and those are under legislation, you have to follow these zones. The best management practices kind of come in with the average retention employed during the within the management zone. And so that's kind of just, I mean, it could be up to the licensee. Like sometimes the licensee will prescribe, just a 5 meter buffer zone, sorry, a 5 meter machine free zone, but sometimes they will actually prescribe a buffer zone. But also just, the R.P.Fs that are actually working on the specific block.
I think this might be the last question.
All right, so Sydney Veres. I have a question about functionality of streams. Can you go back to the graph that looked at the number of nodes for each answer? What is question 6 and question 14 where you're seeing no nodes whatsoever?
Okay. So these are specifically questions for S6 streams. And question 6 and 14, I can't remember the exact questions, but they largely have to do with fish attributes. And so since S6 streams are not fish bearing, they would kind of receive no or NA answers. Yeah.
Really high ones. What was the
What the question was?
Mhm.
Okay. So specifically looking at that first 10 meters of between the stream bank, it's basically indicating that in the south coast, the riparian vegetation within this first 10 meters is highly impacted. So out of all kind of the unhealthy characteristics, that was the one that was found to be most impacted.
Thanks, everyone. Thank you.